We have seen the behavior of increment decrement operators. An increment operator increases the value of the variable by 1 and a decrement operator decrements the value of the variable by 1. If they are used in a printf, we have seen the behavior of those increment decrement operators. If we use these increment decrement operators in an arithmetic expression, let's see how these increment decrement operators are going to behave. So let me use a simple arithmetic expression and try to illustrate these increment decrement operators. For that, let's take up an example. Assume that A is having a value as say 20, B with a value say 10 and C with a value say 5. Let me take 3 more variables int x, y and z. Let me write some random expressions with these A, B and C and try to evaluate these expressions. Assume that I have an expression as x equals to A plus B plus I'll put a space and then I'll say plus C. Let me write one more expression as y equals to minus A plus B plus I'll say A plus. Let me use one more variable as z and construct a random expression as say C plus C plus I'll say plus C. Now I have to evaluate x, y and z in these cases. So how do I evaluate these expressions? Whenever we have an increment decrement expressions, in an arithmetic expression the behavior is completely different and the behavior again depends on the platform which you are going to use. The concepts which we are speaking at this place are purely with a DOS based compiler. If you are working on a DOS based version, probably the behavior which we are speaking is going to hold good. If you are using a Linux based operating system, then probably the behavior of these operators will be different. Let's study the behavior with respect to only one compiler, that is a DOS based compiler. So for that, what I'll do is, for the evaluation purpose, I'll make a table. I'll take variables at this place. Let me say variables as memory. And then I'll write the expressions at this place. Now, I have 6 variables altogether, A, B, C, X, Y, Z. So let's take A as 20, B as say 10, C as say 5, X, Y, Z are garbage values. At this point of time when they are declared, they are garbage values. Now, when an arithmetic expression contains increment decrement operators, this expression need to be solved in 3 steps. You just identify these steps. Once you are through with these steps, you will be able to get the values of x, y, z. Now, first step, whenever we have increment decrement expressions, first step says always solve pre-expressions. Solve the pre-expression. Scan the entire expression from left to right. Scan the entire expression from left to right and solve all pre-increment or pre-decrement. Now let's try the first one. First one is post, avoid this. Second one is post, avoid this. Third one is a pre-increment expression. So C has to be changed to its next value, that is 6. So cut the value of C in the memory, change it to 6. Don't try these calculations in air. Always put these values of the variables on paper, try to change them regularly as we speak. Because when I do the calculations in air, the value of the area variable get lost, so we will not be able to put the values properly. So for that, I'll document these values, change the value of C from 5 to 6, solve all pre-expressions. Remember, first step is solve all pre-expressions. Next step, place the value. I'll call these as 3 P's. First pre, then place and then post. Solve pre, then place the values. Wherever you find the variable, place the value of that. You find a variable A at this place, put the value. A is what? 20. You find a variable B, place the value of this B. B is what? 10. You find a variable C, put the value of this particular C as 6. Solve this particular expression. So this expression will store result into X. So A is 20, B is 10 and C is 6. So 20 plus 10 plus 6 is 36. So this goes into x. Modify the garbage value of x to 36. Right? So first step is to say pre and second step is to place. Now, whenever you're doing this, never ever say that the value of C has been modified at the last, why I'm supposed to place it at the beginning, or the value of A is associated with the post, why I'm supposed to place that. Post expression should not be done at the beginning, they should be always done at the end itself. So let's try the last, that is post expression. So 3 P's are: first solve a pre, second step place the value, and last step is to do the post operations. Now post operations, I have a post expression at this place, a plus plus, change the value of a is what? 20, modified to 21. I have b plus plus, modified to 11. This is pre, which has been all done. So we are through with this particular third step, right? First step, solve pre. Second step, place the value. Third step, then perform the post operations. Let's try the next expression. So I'll divide again this into 3. First is what? Pre. Got it right? So scan the expression from left to right. Perform the what operations? Pre operations. So minus a, reduce the value of a from 21 to 20. Minus b, reduce the value of b to what? 10. Again try the expression. So perform pre, we are through this. Place the value y equals to, wherever find the variable a is what? 20, plus what is b? 10. What is a? You'll say 6. Still it results into same value, that is 36. We have taken the value such that it results into 36. Every time it is not the same case. Next, perform post. First is not post, second is not post, third is, yes, it is a post value. So post is with a is further modified to 21. So value of y goes as 36, a goes as 31. So perform post operations. Last expression is, again divide this into 3 parts. First, pre. So let's search for pre. The first one, is it pre? No. Second one, is it pre? No. Third one, is it pre? Yes, it is pre. So modify this particular 6 to 7. Then place. C is what? 7. Place the value. Again C is what? 7. Place the value. Again C is what? Place the value. 7 plus 7 plus 7 is 21. So I'll say y equals to 21. So we have seen that how the increment decrement operators will play a role. So first step is to always place the pre-expressions, solve the pre-expression. The first one was post, second one was post, third one was pre. Hence 6 was modified to 7. Then it says place the value. So place the value of C as 7, place the value of C as 7, place the value of C as 7. Evaluate the expression. So here Z goes as 21. So Z will get a value as 21. So once Z gets a value as 21, then perform post operation. C++ will be modified to 8 and again C++ will be modified to 9. So the value of X is 36, Y is 36, Z is 21, whereas A, B and C are 21, 10 and 9 respectively. So we can have values of the variables in this particular part. So I've said this with simple expression. Now let's try a simple program on this particular increment decrement expression itself. Suppose if I put these examples into a programming format, let me use simple variables at this place. I'll say int a as say 10, b as say 5. Let me take only 2 variables, x, y. I'll say x equals to a plus plus asterisk b minus minus divided by say again a plus plus, and here I'll say y equals to say minus minus b plus minus minus a asterisk I'll say a minus minus at this place. And now I'll add up some printf instruction. I'll say printf %d slash t %d slash n a comma b, and one more printf with printf %d slash t %d slash n x comma y. Now when a program is going to have printf instruction, then again we are going to have columns of the sort, but this time there will be one more additional column, that is output. and then I'll have memory. And here I'm going to have expressions. Now, let's try and evaluate these expressions. Again, recollect what we said in the previous step. Divide the expression into 3 steps. First step says x equals to a plus plus asterisk b minus minus a plus plus. Before we do that, let's place the values into memory. So a is going to have 10, b is going to have 5, x and y are garbage values. So first step is, first p is pre. Is this a pre-expression? No. Is this a pre-expression? No. Is this a pre-expression? No. So all the 3 are post, hence don't change the values of a and b. Second is P is for place. Place the values. So in the expressions parts, go to the expression part, x equals to a. Value of a is what? 10. Asterisk. B is what? 5 slash a is what? 10. So 10 asterisk 5 is 50 divided by 10 is again 5. So get the value of x as 5. And then it says last P as post. Pre, place, post. So post expression, a plus plus, modify a to 11, b minus minus, modify to 4, a plus plus, modify again this particular a to 12. But the post expressions will not be used in the same expression. They will be used in the further expression. So the latest values of a, b, x, y after the first expression are 12, 4, 5 and garbage. Let's try the next one. Y equals to minus minus b plus minus minus a asterisk a minus minus. Divide this into 3 parts. First step, pre. Is this pre? Yes, minus minus b. Reduce the value of b still further to one more value, 3. Minus minus a, reduce this particular still further to 11. Is this pre? No, it's a post expression. So we are through with the first step. Tick mark the first step. Next, second step is to place the value. Place the value at this place. So I'll write the expression part. I'll say y equals to, here I find a variable b. B is going to have a value as 3. I'll say 3 plus, here I have a value a. A is what? 11. So I'll say a is 11. Asterisk, again a is 11. Now, as per the priority, multiplication will be done first. 11 multiplied by 11 is 121 plus 3 is 124. Now, this has to be stored where? Y. So, y will get 124. Now, we can't complete this particular expression because still there is a third step, that is perform post expressions. So, I have pre which is already done. I have pre which is already done. I have one post which is decrement. So, a is now reduced to 10. So, go to the memory, change the value of a and through with this particular first step. So, when you are writing these into your answer books, never ever use these instructions. This is just for your convincing purpose. So, in the rough work, you can do this. And always show these output, memory and expressions in your answer book rather than a rough page. Because that will create a good impression for the examiner, saying that this is what it has to be written. Now, printf. When it comes to printf, where I'm supposed to go? Should I go into output or should I go into memory? It is in the output part. Percentage d slash d percentage d. A is having a 10 and B is 3. So it says 10 multiple spaces 3. And then the value of x and y. X is what? 5 on the next line and y is 124 and leave multiple spaces and then 124. So whenever it comes to increment decrement expressions, operators, they behave differently. They behave in such a manner that when they appear with printf, they will have something else. When they appear with an arithmetic expression, they will have some different meaning. So when it comes with the arithmetic operators, divide the expression to 3 steps. First step, solve all pre-expressions. Second step, place the value and perform the expression. Third step, perform the post so that the values can be used in the next step. So divide your expression into 3 parts. Always divide your answers into 3 places: output, memory and expression. Output when it comes to printf, memory where the variable values are going to be changing, and expression wherever we have arithmetic expressions involved. That is about the increment and decrement operators. Thank you.